Our first question taken from textbook Formative Exercise 2.4 question 2. So for this question we have a curve, which is the pink color line, and we have the tangent and normal is at point P. It also says that the tangent is perpendicular to this line and it meets the x-axis at point B. So this means this blue line is the tangent, green line is the normal. Okay, so for the first question, we need to find the values of A and B, which is the coordinates of point P. So it's a bit hard to join the points, right? Because to find A and B, the only information gives us is the curve and also this line's equation. Okay. But here it says perpendicular, so I assume we need to use gradient to help us find the values of A and B. Okay, so in this chapter, we know that for gradient, or m, is equals to dy over dx. Okay, so why not, for m, we try to find the gradient of this line, and this dy over dx would be the value of dy over dx at point P. Okay, two things we need to find. Okay, so let's find the gradient of this blue line first. So we know that it is perpendicular to this line, so let's rearrange this line a bit and find the gradient. Right, so this one is perpendicular to the blue line, so to find the gradient that we want, can use this information lah, because it is perpendicular. So this one, if I assume m2 is the gradient that I want, mbp, then if I substitute m with negative 1 over 2, move to the right side, then I'll get my gradient is 2. Okay, so this one is done. And then we find dy over dx using this equation. Okay, so this one is just 2 move to the front, and then later 2i minus 1, we'll get 2x minus 4x. I just extract the value, and plus 1 will differentiate, it will become 0. So this one just ignore. Okay, so now dy over dx, I can change it to m, or in this case mbp. And for this x, technically I can substitute any x value here. So let's say I substitute this x coordinate lah, a inside. Okay, the reason is because I can sub this into here, and then I can straight find my value of a. Okay, so rearrange a bit, I'll get my value of a, which is 3. So now to find b, even simpler, right? Because you can use back the curve equation, x change it to a, y change it to b, and then you just substitute 3 inside the a's, then you'll get your answer, which is b equals to minus 2. Okay, so now onwards, a will become 3 and b will become negative 2. Second question, we define the equation of tangent at P and the coordinates of B. Okay, so two things. So equation of the tangent is actually the line equation lah for the blue line. So to find the equation, we have two things. One is the gradient, which we have already found, which is 2, and a point, which is P, which also found. Right, so this one quite straightforward. Just use y equals to mx plus c, substitute the values inside, find the value of c first, then you will form your equation using the gradient and the y-intercept. Okay, and then to find the coordinates of b, which you can see b and c as well, both of them are x-intercept, which means the y-coordinate is 0. Okay, so using this equation, sub y with 0, then you'll get your x-coordinate, which is 4. So b is 4, 0. Next question, almost the same as part B, it's just now we need to find the normal equation and we need to find the coordinates of C. Right, so gradient and the point. So point we have already, which is P, but the gradient here, okay, so this gradient, quite simple actually, because we know that normal is perpendicular to the tangent, and here it also says this line is perpendicular to the tangent, which means these two lines are, have the same gradient, because technically these two lines, right, are perpendicular to the same line, which is tangent, so technically their gradients should be the same. Okay, so just now for this line, we have found that the gradient is negative 1 over 2, so for the normal gradient, it would be negative 1 over 2. right? So to form the equation, same thing as part B. Okay, y equals ms plus c, sub the values inside, find the value of c, get the equation. And to find the coordinates of c, same thing as well, because c is also an x-intercept, so y value is 0. So sub 0 to y, then you'll get your x value is minus 1. So c is minus 1, 0. And the final question, the area of triangle BPC, which is here. Right? So the fastest way to find the area, quite simple. We can use the 1 over 2 times base times height formula. So now we just need to find the lengths only lah. So since we have already found the coordinates of C and B, right? So technically we can find the length here, right? So from C to 0 is 1 unit, right? Because the coordinate here is -1. Then for 0, which is the origin to B, we know that B is 4, the x coordinate is 4, so here the distance would be 4. And the height, so height is somewhere here, okay, and we know that from this point P, the coordinate here is -2, so this means here to here is 2 units. Okay, so here the base is 5 units, height is 2 units, so the area is 1 over 2 times 5 times 2, then you'll get your area of the triangle.